Okay, this video is going to talk about finding the greatest common factor when you're talking about finding the common factor of polynomials or monomials. So we have, for example, in our first example here, I have two numbers. I have 2a squared, b squared, c, and I also have 18ab to the third. All right, so we're trying to find our greatest common factor of these two monomials. So we're going to do factoring just the same way you would have done factoring if you have just 12. For example, 12, when we do our factoring, it becomes 1 times 12. We could do 2 times 6. We could do 3 times 4. And we could do 4 times 3 again, but then it would just be the same thing. If you go in order like this, as soon as the numbers repeat, like 3 times 4 and 4 times 3, we know we're finished as long as we didn't skip any. So 12, this part, breaks down to this. Then we also have the a squared. When we take a squared, we know what we're saying there is a times a. So that part is the a squared. We also had the b squared. All right, b squared is the same idea. So we have a b times another b. And then we also have the c. So this is a b squared, and then we had c. And c is just going to be c. Okay, when we look at the other number, we had 18. And the 18 becomes 1 times 18. It becomes 2 times 9. And it becomes 3 times 6. All right. We also have the a. Well, a is just a. And then we also have the b cubed, which means b times b times b. Okay, so when we're trying to find the greatest common factor, we're literally finding what these two have in common, and of course the largest one. So as we're looking at these, I can see that for my number portion, 6 is my largest number that they have in common. Right here, this 6 and this 6. So I can take a 6 out of 18 and I can take a 6 out of the 12. And when I do that, it's actually when I take 6 out of, well, actually I'm going to take the 6 out of both those. So this is my greatest common factor between this 12 and the 18. I also, though, have to do the a's, the b's, and the c's. Okay, so since I have at the top, I have a squared, I have 2 a's at the top, and I have 1 a at the bottom. There's only 1 a that they have in common, right here and here. This is the only a that they have in common, so I can pull out 1a. There we go. And as far as b's go, I have 2 b's here, and I have 2 b's here at the bottom that are in common, again, that they have in both of my numbers. So this becomes a b squared here. I do not have a c common down here. There's no c that matches this. So c is not something they have in common, so it is not part of my factoring, or not part of my common factoring, I should say. And so therefore, my greatest common factor between 12a squared b squared c and 18ab to the third is 6ab squared. That is my greatest common factor there. All right, let's do another one. Let's say that we have 6x to the xy to the third, and we have 18yz. Okay, so again, as I go through and I do my factoring, I have 6xy to the third. My factors of 6 are 1 times 6 and 2 times 3. I don't have anything else. I also have an x, and I have 3 y's. 1, 2, 3. Okay, and then I have my 18yz. So again, 18 would be 1 times 18, 2 times 9, and 3 times 6. There's 4 times nothing, 5 times nothing, and then it goes back to 6 times 3. So so that's all my factors of 18. Then I also have times y and times z. Okay? So now again, I'm trying to find the greatest common factor, the number that both of them have in common, the largest number they both have in common. That'd be a 6 here and 6 here, because that's the highest number I have for 6, and 9 and 18, that's too high for the 6 over there. I also do not have any x's in common. I also do not have any z's in common, but I do have 1 y in common right there. So my greatest common factor between these two monomials is 6y, and that is my answer there. All right, we've got one more example, and then we're going to do a little undistributing. So let's say we have this. We have 30 c cubed d squared e, and we also have 50 c squared d e. All right, so my factors of 30, and I'll go ahead and put the whole thing, c to the third, d squared e. My factors of 30 are 1 times 30. Again, I do the next number, that's 2 times 15, then 3 times 10. 4 doesn't work. 5 does work, 5 times 6. And then 6 times 5 would be the same thing, so that's all of my factors of 30. And then I have 3 c's, 1, 2, 3. I have 2 d's, 1, 2, and I have 1 e. All right, when I do my 50 c squared d e, I have 1 times 50. I have 2 times 25. And I don't have a 3 times anything or a 4 times anything, but I do have 5 times 10. And again, 6 times nothing, 7 times nothing, 8 times nothing, 9 times nothing, comes back to 10 times 5. So that's it. That's all of my factors of 50. I also have a c twice, I have a d once, and I have an e once. All right, so we're going to find the greatest common factor between these two numbers. It looks like it's 10. We have 10 here and 10 here, so that's my greatest common factor for the number part. So 10 starts there. I have 2 c's down here, 1, 2, and I have 2 up here. So that's going to be c squared. And then I have a d down here and a d up here. That's going to be d. And I have an e down here and an e here, so it's e. So my greatest common factor between those two is 10 c squared d e. Okay, one of the things also that we're going to start doing is sort of undistributing, is kind of how we're going to call it. So this is undistributing to factor out. So for example, if I have this, what I'm going to do is the same thing I just did a moment ago, and I'm going to pull out the greatest common factor between 15x and 25x squared. So the greatest common factor between 15 and 25 is 5. I can pull that out. And I also have an x common with both, so I can pull out one of the x's. When I do this, I have to think about what I have left over. This is the hardest part, is I have to think about what's left. So what did I pull out, or what did I multiply 5 to get 15? I multiplied it by 3. So if I do 3 times the 5x, that's going to give me that 15x. What can I multiply by 5 to get 25? That would be 5. Now it was an x squared, so I'm actually going to have to multiply by 5x, because x times x gives me the x squared. So this would be my final answer for this, because these are my factors. I have 5x coming out of the 15x plus 25x squared. And when I pull out that 5x, I'm left with 3 plus 5x. So the key thing is to look and see what you are left with. Okay, here's another one here. We'll do one a little bit trickier. We have 12jk squared plus 6j squared k plus 2j squared k squared. These always kind of drive me crazy because I get all my letters and numbers mixed up with this. All right, let's start with the easy part. Let's take out the largest number that we can take out. Well, between 12, 6, and 2, the largest number I can pull out is 2. And now I'm going to have a big parentheses here for the rest of what I'm doing. Fortunately, it's all going to be adding, so that part makes it easy. All right, so I'm going to pull out, I pulled out the 2. Now I'm looking at j's. I have a j in my first term. I have a j squared in my second term, and I have a j squared in my third term. I can pull out one j, and actually I need to fix this. Let me do this again. Sorry. So I have 2, and I pulled out one j, and then I can also pull out one k, because this is the only one I have a k for. So I'm going to pull out the k there. All right, now let's see what we have left. I pulled 2 out of 12, so 6 is left over. I pulled out the j, and I pulled out one of the k's, so I have 1k left over. So my first term now is 6k, plus, from the 6, I pulled out the 2, so that's going to be 3 left over, because 2 times 3 is 6. And I pulled out 1j, so 1j is left over. And I pulled out the k, so it's gone. I don't have a k now, because that k was taken out. Now I'm going to add again. And when I pulled out the 2 here, the 2 is gone. I pulled out one of the j's. There were 2 there. I have 1 left. And I pulled out one of the k's. And so again, there's 1k left. So this is the answer to that one. It's possible that there's nothing we can do as far as pulling things out. For example, if we have this, 5x squared minus 3x minus 7. They have nothing in common. First of all, those numbers are prime. 3, 7, and 5, they're all prime. And so they don't share a common factor other than 1. And I can't pull anything out. There's not a common x with all of them, so I cannot pull anything out. We literally would just say, instead of doing any kind of math, we would just say that this one is prime. Meaning, that's it. That's all I can do. I can't factor that any smaller. All right, so this is our video on greatest common factor and undistributing to factor out the GCF.